Great. Hey, everyone. Welcome to another edition of Hypermode Live. My name's Will from the Hypermode team. And today I have a very special guest, Curtis from Google. Hey, Curtis.
Hey, Will. Thanks for having me.
Yeah, thanks so much for joining today. So today we are going to talk about building AI agents with Dgraph and Google's GenAI Toolbox and LangChain and these cool tools like this. But before we get into that, I've been hearing a lot about Google Next coming up. This is what in a couple weeks. I think this is like Google Cloud's developer conference. Is that right, Curtis?
Yeah. It's our yearly conference, and it's I think as of last year, this started happening in April again, and so it's going to be in Vegas in 2 weeks. So very busy here at Google. Lots of all hands on deck things. So
Nice, awesome. I imagine AI agents and Google Cloud database tools. Imagine a lot of like deep dives into those kinds of things with Gen AI things like VertexAI, all those sorts of interesting Google Cloud tools, right?
yeah, there's going to be quite a few interesting sessions. I actually have one with Harrison Chase from LangChain. He's going
Oh,
to talk
cool.
about LangGraph and how we use Toolbox and stuff like that. There's another one with Jerry Liu from Llama Index and Hamza, who's my PM counterpart for databases and GenAI. And then there's a bunch of other talks in a similar vein. We've got some folks doing some on NL to SQL and some of the improvements we've made there. Lots of cool talks. So.
Cool. Awesome. Good stuff. Well, thanks again, Curtis. Thanks so much for joining today. Before we get started, do you want to maybe introduce yourself to the crowd and just say a little bit about what you work on?
Yeah, of course. So my name is Curtis Van Gent. I'm a software engineer at Google, and I work on ecosystems and integrations for GenAI in cloud databases. So my job is really to figure out how to get cloud databases to be used for a variety of different things and tools. That includes some internal things like integrations that we work on with like VertexAI and their platform. It also includes a lot of external things. So LangChain, Llama Index, things of those nature, and of course Toolbox, which we'll be talking more about today.
Awesome, great. Well, yeah, let's get into it. And by the way, for folks watching, we're streaming both on YouTube and LinkedIn. I've got the chat open here so we can see any questions for folks have. I'd love for this to be as interactive as possible. So please feel free to drop any questions you have in the chat, and we'll be sure to get to those during today's session. And just to kick us off, it's always great to just let us know where folks are joining from. I'm always amazed kind of how global these events are, which is super cool. All right, I'll go ahead and share your screen there. Great. Well, let's go ahead and dive in.
All right. Today on the agenda, of course, we're going to be talking about Dgraph and how Dgraph works with Toolbox. The kind of agenda we've laid out for today is number one, if you're not familiar with agents, I'm going to try and give a brief overview of agents and tools and kind of how they work and why they're important. Then I'm going to talk about GenAI Toolbox and how it can be useful in building agents and some of the cool features that it has. And then I'm going to hand it over to Will, and Will's going to talk a little bit about Dgraph and Toolbox together. He's going to show us a cool demo that he's put together. And then finally, we'll come back to me, and we'll talk about some of the things that are on the roadmap for Toolbox, and then we'll open it up to a Q&A session. So I see a comment there from Christo. He's already asking about that. Yes, we will be doing a Q&A at the end. So feel free to drop your questions in the chat, and we'll kind of respond to them as we go as well. So. Okay, so first let's talk about agents. A lot of talk about agents. Agents have become really popular in the last year. I've been working with them for like a year and a half now, so I got into it a little bit earlier, and lucky enough it took off, which was fortuitous for us. So let's talk about like what exactly is an agent, because I think there's a lot of ambiguity here. Agents are applications that use like generative AI models to think and act towards goals. So you can think of the LLM as an engine for an agent. And it can be used for a bunch of different things, usually when you want some kind of intelligence. So it can make it easier to automate complex workflows. It can use reasoning and planning to determine what steps it needs to take. And then it can use tools to act on those steps. Do things like access data, take concrete actions. You can query your database. You can call an API. You can do essentially anything that you can automate. You can pass as a tool to an agent. And so AI agents plan, they reason, and then they execute. Again, you can think of the orchestration as kind of like the agent's brain. This is what the model is going to be used for. It's coordinating how the model is thinking, what prompts, where stuff is stored in memory. And then you have a bunch of these tools, which are going to like fetch data, perform actions, and things of that nature. Essentially, any action that you can code, you can get an agent to essentially take as an action. And all of this has to be deployed somewhere, so you'll want to execute the system, make sure that your agent is running in a location, and there's a lot of different solutions for stuff like that. Tools, I think, are a very interesting thing because they allow the agent to kind of transcend what it would just otherwise be text, and give it some agency outside of itself. So tools, or sometimes they're called function calling, let an LLM take actions beyond generating text. They're any arbitrary function. So most tools are really just like a Python function that you can pass. And then whenever the agent decides to take that action, the orchestration platform translates that into executing that function and returning the results back to the agent to continue the generation. When it comes to database tools, there's really like three main categories. You see semantic search, which was really hot for a while last year, where you do an embedding on some string, you do a lookup like that. You're also seeing some variations now with hybrid search as well. You can also have structured queries. So sometimes you just need to look up database in your database. And so someone goes and they writes a SQL statement ahead of time, and the LLM just provides some arguments inside that statement. These are a lot better when you're accessing data where you need to have high confidence. You need to make sure it's the right data. You want to control your access to that, make sure the LLM doesn't go awry. And last but definitely not least, you have in-analysis SQL tools where you ask the agent, or maybe the agent asks another agent to generate some SQL statements and then execute those in the database for you. This last category is still a bit of a work in progress. I think in-analysis SQL has some good uses, but a lot of the accuracy isn't there that you can kind of use it all the time. So you kind of need to be okay with in-analysis SQL with sometimes you're going to get wrong statements. It's better if you can have a human in the loop that can verify that SQL statement, and you need to put some like strong controls around what data can be accessed so that the agent doesn't expose data to the customer that it shouldn't. And you can see that these tools end up being how the agents are going to interact with systems. So as you can see here, we have kind of a multi-agent architecture set up where you have the customer asking a question to the agent. The agent is going to go gather a bunch of information using tools. It may delegate some of that to other agents that are specialized to work in those different systems. So you have an agent here that does CRMs, you have another agent that does marketing, you have another agent that does sales. All of these things have to have a bunch of custom logic that allow the agent to interact with those systems, get the information they need. So let's kind of move on to Toolbox and how Toolbox can help you design and develop agents. So right now, I mentioned in the last slide, there's a lot of custom logic that's involved, and this gets worse when you look at different orchestration frameworks. There's orchestration frameworks for just about everything, and so you end up having to kind of replicate a lot of your logic, especially if your team or your organization isn't using the same framework across everything. You have to write a lot of custom logic to interact with your systems. So you end up writing tools for interacting with Postgres, or tools for interacting with Spanner, or tools for interacting with resources like Dgraph. And all of that can be a lot of different work. So the reason we introduced Toolbox is Toolbox sits between your orchestration framework and your database and makes it easier to develop those tools in kind of a uniform way. So it doesn't matter if you're using which orchestration framework you're using, if you're using LangGraph, if you're using Llama Index. It also doesn't matter which database you're using, as long as it's supported by Toolbox. You can pretty easily bootstrap a bunch of tools and start interacting with them immediately. And you get a bunch of cool perks from using Toolbox as well. So Toolbox really kind of streamlines the development because it replaces this custom logic with like a unified control plane almost that gives you observability. We have things like OpenTelemetry, which I'll talk about in a little bit. We have a lot of cool features that make it easier to develop more secure tools. And we also make it easier to scale those tools. We do a lot of best practices, such as connection pooling and things like that, to make sure that you're efficiently interacting with your database, as those can often be bottlenecks for folks. It's really easy to integrate Toolbox with your SDK. Here's an example of what it looks like using LangChain. All you have to do is point the Toolbox client to your server, and then you can load the tool set. All of these tools are ready to be passed to your agent. They mimic the tools in that orchestration framework, and you can kind of use them out of the box like that. So let's kind of talk a bit about how Toolbox works and why this is so easy. So step one is you kind of define the tools. You go to Toolbox and you say, like, here are the tools that I want. We have a bunch of different types of tools. Some tools can be used from multiple different sources. Some tools are specific to a source. But you essentially just write a YAML file that we call a tools.yaml that defines how you connect to the databases and what tools you want. Then you go to your SDK, you plug in those 3 lines of code that I just mentioned, and you load the tools. And essentially what happens is, as you update tools in Toolbox, your orchestration framework, every time it loads tools, will always get the latest version. And then whenever those tools get triggered by the agent, it actually sends an HTTP request to Toolbox, which translates into accessing your data. This allows Toolbox to kind of sit in the middle. It allows you to have like a consistent way to interact with tools. You can share tools between different agents, between different frameworks. And when you invoke the tools, you get a lot of the benefits that Toolbox can add by being in the middle there. So let's talk a little bit about like what configuring a tool looks like. So I mentioned earlier that we use a tools.yaml file. There's really 3 primary things that you have to configure. The first is a source. And so these are going to be things like sources, tools, and tool sets. The source is going to be a database and like how you connect to it. So taking a look at what the source looks like, here's an example source for Dgraph. It's going to encapsulate how you connect to a database. It's going to be things like IP address, credentials, maybe that's a username and password, maybe that's an API key. Essentially, this tells you how you're going to connect to that database and how we're going to establish that connection pool on your behalf. Second, you need to define the tools. And so tools are always an action that get executed usually on a source. They include things like what kind of tool it is. So in this case, we're looking at a Dgraph tool. It says what source you're connecting to, so we can connect to the source we specified in the last step. You also specify a statement. So here's an example of the DQL statement that Dgraph uses that will get executed. And you can see that there are a bunch of parameters that can get passed in there. And so you specify what those parameters are. You specify if you want them to be timed out. You specify the description you want to pass to the LLM that tells the tool, or that tells the agent how and when to use the tool. All of these things are kind of defined in one place rather than being filtered and rather than being spread across your application. And when we generate the tool, we pass them into the LLM for you automatically. Last but not least, you can define tool sets. Tool sets are these logical groups of tools. So you can create a bunch of tools and then share them between multiple agents. So you can use a tool set to say, like, these are all my read tools. You can say, these are all the tools that agent A needs, and agent B needs a different set of tools. This allows you to kind of organize those tools in whatever way works best for you. It makes it easier to access and load them. And so, like, as you kind of update tool sets and as you update your tools, your client can always be pulling down the latest version of those. On the client side, it's really easy to specify a tool set. When you call the load toolset method, all you need to do is pass in the name of the tool set, and it'll automatically pull that list of tools. If you don't specify a name, it'll just pull all the tools. We have some cool features that you can use with Toolbox as well. So I mentioned earlier that security is a really big issue that you have to worry about. One of the features that we have is called authenticated parameters. So you can imagine a scenario where a user is asking, what time does my flight leave today? And so what you want the agent to do is go look up tickets that user has that are booked for whatever today's date is, right? Now, if you ask the agent to do those things, you run the risk of someone being able to trick the agent into thinking it's a user that it's not supposed to, or that its user ID is something that it shouldn't be, and essentially exposing data in your database to like a malicious actor. What authenticated parameters does instead is it allows you to say, hey, this parameter needs to come from an OICD token. The advantage of this is you can have the user sign in. So we have an example here of sign in with Google. They get that OIDC token. That token is automatically bound to the tool. You can pass it in with some application logic. And then whenever that tool gets invoked from that agent, the value gets automatically determined. Toolbox unpacks that token, validates that it's the right token that's signed in the right source, and then puts that value out of that token into the SQL statement automatically. So you can see here, the user is asking what time does my flight leave today. The agent is calling a tool that only specifies the date, and then we're deriving the user ID of the user from that token instead of from the LLM instead. This gives you the advantage of a much more secure pattern of being able to essentially say, hey, I want to make sure that this user is signed in, and specifically that they're only accessing data that they're supposed to use. Configuring authenticated parameters is pretty easy as well. Right now, we only support the one, which is the Google sign-in, but we've built this to be kind of abstract. So if there's another kind of auth service you want to add, it should be easy to add. You just need to specify what kind of auth service you're using, which right now we have the Google sign-in. For client ID, you just specify the client ID that matches, and then we'll do the hard work of validating that token. On the tool side, you just have to add these 3 lines at the bottom here, which essentially says auth sources, so like where you want to source this token from, and then the name and field of the name of the parameter and the field you want to pull that out of. So if you want to use user ID, you just specify user ID, and we'll automatically pull that field out of the token and map it to that parameter. We also have some cool features around authorized invocations. So you can require an authorization check to a tool. This uses the same kind of mechanism with the token we talked about before, where whenever you invoke that tool, we validate that that token is in fact allowed, it matches the rules that you've set, and then that allows you to trigger the tool. So if for whatever reason, you want to select flights, you want to make sure that this person is authenticated correctly, you can essentially, with a couple of lines of configuration, enable it so that the token invocation is gated on, the tool invocation is gated on the token. We also have observability. So I mentioned this earlier. We have structured logging with one flag. You can automatically get structured logging. You can see everything Toolbox is doing in a way that makes it easy to consume and digest. We also have metrics and tracing. So we plug in through OpenTelemetry. So anything that works with OpenTelemetry, you can plug Toolbox into. You can start seeing your exports. You can get traces. You can see exactly how long it's taking to execute a tool. You can see how long the query within the tool is taking, how long it's taking to connect to the database. Things like that are all super visible, which makes it easy to kind of debug and figure out what's wrong with your tools and how they're working. We also have some documentation. So we have a doc site. It has some really good features. Developer experience is a big part of Toolbox for us. One of the things you can do with our doc site is you can search all of the documentation. There's a bunch of guides and quick starts to get you started, reference documentation on how you can configure all of these things. We also have dark mode. I know everybody loves dark mode. This makes it really easy to kind of figure out how to use Toolbox correctly, how to get everything up and running, and how to figure out what it is you're trying to do. We have some cool deployment guides. So if you're looking at deploying to Cloud Run, GKE, we have another one for Docker Compose. We have some detailed documentation to get you started deploying Toolbox to a specific location. And check those out, and it'll make it easy for you to get this thing up and running as quickly as possible. Now I'm going to hand it over to Will, and Will is going to give us a demonstration of Dgraph and Toolbox together.
Cool. Thanks for that overview, Curtis. As I'm getting my screen share working here, maybe I can ask you, Curtis, what's been the reception of Toolbox so far, right? So this is an open source project, I think was released sometime in February, is that right? So fairly new project. What's
Yep.
some of the feedback or like the general reception that you've gotten so far?
I think the feedback has been kind of beyond what we expected. We've had quite a few folks reach out. Neo4j was one of the first contributors to this, Dgraph as well. You guys were in our private preview. You guys contributed tools before we had kind of publicly launched. We've got a lot of other folks. We've had companies like Box reach out. We've had companies like Couchbase as well that are all kind of interested in using Toolbox. Similarly, we started by launching support with LangChain. We added support for Llama Index a few weeks ago. We'll be talking more about some of the upcoming stuff on our roadmap, but it does feel like we have a lot of momentum and a ton of people are interested in using Toolbox.
Cool. That's great. Yeah. I mean, I think this definitely fills a need. I remember, trying to build data-rich agents, several months ago last year, and just that problem of managing connections to the database, managing connections to multiple database, multiple data sources, just having some structure of defining tools was a bit of a challenge. So this when I saw this project, it made a lot of sense to me to kind of fill a gap in the market. So very cool to see this. Cool. Well, I'm going to talk a little bit about using Dgraph and Toolbox together. So as Curtis said, Dgraph support was added to Toolbox before it was publicly released. This is a blog post that we wrote in February on the Hypermode blog when Toolbox launched, is kind of talking about why and how we added support for Dgraph to Toolbox, and a bit of an example of exposing Dgraph as a source. And so that's a good post to read for a little background on, I think, why we thought it was important to expose Dgraph. I think that we'll talk a little bit about this coming up, but I think that knowledge graphs are really important for building agentic flows, building AI agents by providing rich context. And Dgraph as a graph database can be used as a knowledge graph for these AI workflows. But let's maybe back up a little bit. So at Hypermode, our goal is really to enable developers to build and host agents and graphs. We're very much an open source company. So the open source developer tools that we build and maintain are Modus, which is our AI agent framework, Dgraph, which we're going to go a little bit deeper in today, which is a scalable real-time graph database, Badger, which is a key value store, and Ristretto, which is a cache library. These make up the sort of the core portfolio of open source projects we build and maintain, and then we aim for Hypermode to be the best hosting experience for agents and graphs built with these tools. Hypermode platform also has model hosting functionality, things like this. But let's talk about Dgraph and kind of zoom in on Dgraph, which is what we're going to take a look at today. So Dgraph fundamentally is a graph database. So it allows us to model, store, and query our data as a graph. We'll talk about what that means in a minute. But specifically, Dgraph is a transactional and distributed graph database. That means it's optimized for transactional workloads. So features that are really important for this are ACID transactions, MVCC for managing multiple requests, multiple writes that come in, Raft for managing consensus around commits. Dgraph was actually very much inspired by the architecture of Google Spanner for how it implemented scalability and sharding. Dgraph exposes the property graph model for data modeling and querying, and uses DQL as its primary query language, also support for GraphQL. We'll look at those in a minute. But the sort of the smallest unit of record, like in a relational database, might be like a row in a table. In Dgraph, that smallest unit of record is a triple. So subject, predicate, object, which we'll talk about again in a minute. And we're also, Dgraph, we're using RDF or JSON for data interchange. So for mutations and adding data to Dgraph. Let's take a look at DQL, which is the Dgraph query language. So DQL was very much inspired by GraphQL. So Dgraph was first released in 2017, which was shortly after GraphQL was open sourced by Facebook. And I think there was a lot of interest around this idea of modeling your application data as a graph and querying that with GraphQL at the API layer. And so the DQL, the Dgraph query language, borrows a lot of those concepts and ideas from GraphQL, but adds some additional functionality because fundamentally GraphQL is not a database query language is meant to be an API query language. And so DQL, for example, adds this concept of functions, like in the example here with this filter function. That's kind of something outside of the scope of GraphQL that gives you this additional like database query functionality that you would want. But if you're familiar with GraphQL, looking at this DQL example, you can see that there are some similar concepts. So in a graph database, a query is basically describing a traversal through the graph. And in each of those queries, we need a starting point. So you need to identify the first node or a set of nodes to start that traversal from. And that's this root criteria here in DQL. So in this example, we're saying find a node where the name is Indiana Jones. That's the starting point for our traversal. And then the way that we sort of traverse the graph in DQL is with this nested structure, very similar to GraphQL, where we describe this nested structure, and each one of those is a traversal through the graph. And then DQL allows us to add additional functions, either at the root or at each layer of this selection set. So then when the data comes back, very similar to GraphQL, the data is JSON. The result of our DQL query is JSON that matches the selection set, matches the structure of our query. So here we can see, we start with the movie node Indiana Jones, we see the node attributes, and then we see the relationships represented by this nested structure in the data. Now, I said earlier that Dgraph exposes a property graph model for how we sort of model and think about the data that we're storing in the database. But we also work with triples and RDF. And this may seem a bit contradictory for folks who are familiar with the graph database ecosystem. These are typically thought of kind of like two separate types of graph database. You have your property graph databases and you have sort of your RDF triple stores. And Dgraph is really this interesting, almost hybrid of these two approaches. So it exposes a property graph model for the developer to think about and model their data. So the property graph model is composed of nodes. These are the entities, the things in the graph. We have relationships that connect nodes. Nodes have a label, which describes like the type of the thing that it is. And then we can store arbitrary key value pair properties on both nodes and relationships. So this is the property graph model. If we go over to this concept of a triple, with a triple, again, I said this is the smallest unit that we work with in Dgraph. We have subject, predicate, object, where the subject is a node. So here we're saying Bob. The predicate can then be a relationship, or it can also be a property. So Bob can follow Will. Will can have an age. And then the object can either be another node if the predicate is a relationship, or it can be a value if the predicate is a property. So Bob follows Will. That's node, relationship, node. Will, age 29, node, property, value. And what's interesting about Dgraph is that allows us to work with conceptually and at query time, the property graph model, but then kind of under the hood, working with triples and optimizing the way that we're storing those in Dgraph, but optimizing for traversing the graph. Many triple stores are optimizing for things like imposing an ontology, inference, reasoning, that sort of thing. Dgraph as a transactional database is optimizing for traversing the graph and leverages the concept of a triple to be able to do that in a distributed environment very efficiently, which we can go into a lot of detail on how that works. It's actually quite fascinating. The paper that I linked in a couple slides earlier, I think goes into a lot of detail of how that works under the hood. So if you're curious on that, that's a good read. I talked a little bit about why we thought it was really important to add Dgraph to Google's GenAI Toolbox as a data source. And specifically, we want to be able to expose knowledge graphs for AI agents to provide this rich context for agentic workflows. That's the fundamental goal, and I think it's really important for Dgraph to be a part of this ecosystem. Ryan, who leads our product and engineering team at Hypermode, wrote a blog post just a couple days ago that goes into a lot more detail of how we're continuing to invest in Dgraph, some of the serverless Dgraph hosting on Hypermode that's coming soon. That's quite exciting. So if you want to read more about how Hypermode is enabling knowledge graphs with Dgraph, this is a really good read. Cool. Well, as Curtis promised, I do want to show a demo of using Dgraph with GenAI Toolbox. And so I put together an e-commerce agent. This is going to use GenAI Toolbox, Dgraph, LangChain, and Postgres. So I wanted to show a world where we have a polyglot database environment. So we have multiple databases, and the agent needs to be able to interact with both of these databases through tools. And depending on the query, depending on what the agent is trying to reason about, trying to fetch data to resolve, it's going to select from multiple tools, and those tools can be functions to interact with either Postgres or Dgraph. And so the interface is like a natural language chat. We're using LangChain as our agent orchestration framework. Just really wanted to demonstrate kind of how that works with Dgraph in that LangChain ecosystem. And so the goal is really help us to find product details, leveraging user reviews for product recommendations is really the goal of this demo. And so I took this data set from UCSD maintains a data set of Amazon reviews over the years. So the most recent version is from 2023. They make it available on Hugging Face, grouped by category, which is quite nice. And so there's user reviews, product description, and then also products purchased together. It's like co-purchase graph there as well. And I took the appliance category, I think, which is just almost 100,000 items, couple million reviews, and loaded that into Dgraph and also Postgres. So we loaded the user reviews into Dgraph and kind of the product catalog, like the metadata into Postgres. And so this is where graph databases come in. This graph traversal. If you're wondering why would we use two databases to sort of back this e-commerce use case, well, we may want to maintain a table of products for our product catalog in something like Postgres, where we have basically one row for each product and the metadata for each product. But then what if we want to, say, generate personalized recommendations leveraging user reviews? And this is a really common use case for a graph database, which is optimized for traversing the graph and doing that very quickly and efficiently. So here's an example of a DQL query that is basically saying, okay, if I'm looking at a product, or if I've purchased a product, what are some other products that I might be interested in using user reviews? So first, we have kind of the product ID as a parameter here. So we look up the product. Then we find users who have purchased this product. And then for users who have purchased that product, what other products are they purchasing? And get a count of sort of that number of co-purchase users who have also purchased other product. And those are your recommendations. So that's an example of the type of graph database query that we want to use to facilitate recommendations. Cool. So here on the right, I have a client for Postgres. So I just have this running locally for simplicity here. So I have one table, products. This has all of the product info from the appliance category. You can see we have things like brand, ASIN, which is the product ID, some description, category, price, that sort of thing. And so I can write queries like show me products where the title contains Whirlpool, and here are like some of the Whirlpool products, those sorts of things. On the left, this is Ratel, which is a client for Dgraph. And so you can see here, this is kind of the schema view, the description of the data that I have loaded in Dgraph. And here's a simple DQL query. So I want to find the first 10 reviews, give me some details of that, then find the product that we're reviewing and the user who reviewed it. And so I get kind of this graph view. Here's the review. This is a 5-star. Product came quickly. Great. It was written by this user and of this product. I'm not storing the product or user details in Dgraph, so we don't see those details here. Here's the JSON representation. Remember in that example that I showed, the result from our DQL query matches sort of the selection set in our query, very similar to GraphQL. Cool. So that's our two data sources. Let's take a look at some code here. So the first thing we did is we configure our tools.yaml file for Toolbox. And we have two sources here. So one is Postgres, just running locally, and one is Dgraph, running locally. And then here we define our tools. So I just defined each tool individually. I didn't use a tool set. And we have some tools that are parameterized SQL queries that are going to expose data via Postgres, and some are DQL queries that will be leveraging Dgraph. So for example, we can search product by title, and it's really important. Let's see if I can wrap. There we go. It's very important, I think, to make sure that your description of these tools provides enough information because it's the model, it's the LLM that is going to leverage this English language description of what this tool is providing. So that's something to consider as you're defining your tools.yaml. And then the parameters. So in this case, this is search product by title. Here's the parameterized SQL query that just takes a name, searching the title column. We can also search product details by the ID number. And then in DQL, so for our Dgraph source, we have tools like get product reviews, where given a product ID, we can traverse the graph to find, okay, what reviews mention these product, what are the reviews in text, and we can search that by ASIN. And so I can start the Toolbox server. So we found two sources, 3 tools, and so our Toolbox server is running locally and ready for our agent to interact with it. So here's the code for our agent. Again, I used LangChain for this. So there's a Toolbox client LangChain package that we're bringing in. We are connecting to the Toolbox server locally and loading the tool set. And of course, we need a model. We're using the Google VertexAI LangChain integration here. We're going to use a Gemini model. And then our models need some buffer memory, so it's chat history. So as we interact with our agent, we want, we don't want like each natural language, chat message that we send it to be kind of a whole new sort of way of interacting with the agent. We want the agent to have some history. So the different ways of storing that, we're just keeping that in memory here. And then our agent is going to have a prompt. This is important to define sort of the system prompt. And so we're saying, hey, you're a helpful search assistant. You're going to give us details about product information, use the tools that we provide. And then we inject the chat history here as well, so that the prompt, when we go to the LLM, has the message history as well. We're using Gemini 1.5 Pro from VertexAI. And then we pass all these pieces, the LLM to create the agent, the tools, and then our memory to create our agent executor. And then this is just kind of an interactive loop so that we can chat with our agent. So let's go ahead and run that. Python e-commerce agent. And so this is going to start our agent. So we're going to load the tool set from Toolbox. We're going to, and actually if we switch back in the terminal here, we can see here the result in the logs from Toolbox that we had a request for /API/toolset. So this is our agent saying, hey, give me the description of all the tools that you have available. And now we're ready for our first message. And so let's say I'm looking for an ice maker. And so now our model is going to decide, okay, well, you're looking for an ice maker based on the data that I have, like in my training, and I know I'm supposed to use these tools. Like, do I have enough information available to respond to this? And I have debug mode on, so we can see the whole history here. And so the model's decided, well, let's call this search product by title tool, and we'll pass in ice maker as the parameter. We can see the data that we get back from the tool. So this is basically invoking that parameterized SQL query in Postgres. And then the model summarizes this information like, hey, I've got several ice makers. Here's some examples. Do these sound interesting? Are there more options? Do you have other criteria in mind? Let's say summarize the reviews of the Robeson ice maker. So I want to know, okay, tell me about the reviews of this. And we can see here that now we're calling two tools. So it's going back to search product by title for Robeson ice maker machine countertop. And so it knows that's the ice maker I was referring to, and I said Robeson ice maker, and it's doing this to get the ASIN number, and so it knows that it needs this ASIN number to go to our Dgraph tool to find product reviews, passing in the ASIN number to get the product reviews, and we have average rating, and we have some basic review information. Cool. So that was a quick look at our e-commerce agent. We can leverage multiple databases here using Toolbox and LangChain, which is pretty neat. I think this is a pretty fun one to play around with. If you're interested in learning more about this specific example and Dgraph with Toolbox, I wrote a blog post with Hamza, and Curtis helped with this one as well. So thanks for that. This is on the Google Cloud blog. So that's a good read that goes into a bit more detail of kind of behind the scenes of this demo and links to the code as well. Cool. So that was kind of my rough overview of Dgraph and a look at that demo of using Dgraph with Toolbox and LangChain and other databases for the e-commerce agent. Curtis, do you want to talk a little bit about kind of what's coming up in the roadmap for Toolbox?
Yeah, let's do it. You want to go awesome. So I mentioned earlier we announced support for Llama Index a couple of weeks ago, and so that was really nice to see. We collaborated pretty closely with both Lori and Jerry from Llama Index on that. We have a bunch of other things coming for the next few weeks. Number one is support for MCP. Lots of folks, especially if you're working at agents, have probably heard of MCP. We're trying to add support for that protocol in Toolbox itself, so you'd be able to connect to Toolbox with an MCP client. We're also looking at adding HTTP tools and sources. We know that like structured queries don't kind of satisfy all use cases, but if we give the ability for you to kind of plug in whatever API you have, you can kind of make tools for whatever reg pipelines you have. So if you have like a more complex, say Llama Index, or maybe even like LangChain engine where you're doing lots of complicated things for looking up information, you can deploy that to a server and expose it as a tool in Toolbox, which is pretty cool. We're also looking into base SDKs. So these are like SDKs that have the core functionality for Toolbox, but kind of plug into more things. So instead of just working with LangChain and Llama Index, we'll have something that like generates Python functions or generates Go functions that you can kind of plug into a lot of different things, hopefully without a lot of extra work. We're also working on adding better support for Toolbox and collabs. We know a lot of folks like to develop, especially AI things in collabs. We're trying to make it easier to use Toolbox in there and maybe even have like a starter kit to get you started running that. Longer term, so like after the next few weeks, we really want to get some more diverse tools. We have that structured query tool for a lot of different databases. We really want to start adding tools for things like semantic search, hybrid search. We want to add some tools for NL to SQL. I think AlloyDB specifically has some really cool NL to SQL features we're looking on leveraging. We want to add more SDKs. I mentioned Go earlier. We want to add Java and Node as well. And then we really want to get like an advanced control plane in this thing. Right now, I think deploying and managing a tool works if you only have like a couple of Toolbox servers or if it's relatively static. We really want to make it so you can have, dozens of Toolbox servers and you can deploy a tool and it goes to all of them. And so those are kind of the things that we're looking at after we finish our next ramp up. So for all the folks listening, please go check us out. Our GitHub repo is github.com/Google APIs/GenAI-Toolbox. We're completely open source. We develop out there on GitHub. So you can see a lot of the PRs for a lot of the things I mentioned are kind of in flight right now. I mentioned we have a cool documentation site as well. The URL for that is googleapis.github.io/GenAI-Toolbox. So again, we spent a lot of time in making the docs kind of easy to read and navigate and do things like search. And finally, if you're looking at anything, you spot any issues, you think, man, I would really love to use this, but it needs some feature that's not in there. Please stop by, file a bug, file a feature request, open an issue. We'd love to engage with you folks. We really want to build Toolbox to be something that everyone finds super useful. And so we really need feedback and contributions, including PRs if you're interested. Like, again, everything is open source. And so the beauty of that is anyone can kind of contribute and add to Toolbox. So if it seems like something you're interested in, please stop by, give us a try. Let us know how we can do better. Feel free to help us do better as well if you have spare time. So.
Awesome. Good stuff. Here is a link to the slides. So you can grab that, that QR code. I'll get us off to the side there so folks can grab the QR code or hype.foo/toolbox-graphql, and I'll drop a link to that in the chat. Great. So we have a few minutes left. We can take some questions if that sounds good to you, Curtis. I'll take a look in the chat here. Let's see. So we have some comments that this didn't know Toolbox looks more than interesting. This looks amazing. Very cool. So folks are pretty interested learning about Toolbox. That's great. Thanks for the feedback. One question to kick us off here. You mentioned MCP, Model Context Protocol, and adding support to Toolbox so that, if I understand this right, so an MCP client would be able to connect to the Toolbox servers. Is that kind of the scope you're thinking? Maybe we could take a step back and maybe how would you compare Toolbox in general to MCP? Because I think I see there's some similar concepts, right?
Yeah, that's a good question. We actually get that quite a bit. We came up with the idea for Toolbox a little bit before MCP, well, quite a bit before MCP was launched, but MCP is more of a protocol. So it's like a standard way of doing things that like Toolbox is trying to do. So I think the interesting thing there that is that they're both solving the same problem, but Toolbox is an implementation and MCP is really a protocol. So MCP is like a standard way of doing that thing. The cool thing about MCP is the more folks that get on board, the more the less work there is actually for us on the Toolbox side is we can have one protocol that everyone kind of understands and everyone can interact with. And so if you have something that is an MCP client, you can interact with Toolbox without a bunch of extra work. And so there's some really cool things there. I'm like, if you speak MCP, your application can connect. And there's lots of folks that are adding support for MCP. So it's been really cool to see that kind of get traction. We've actually been talking to Anthropic folks about it. We're pretty excited about MCP. The one thing I will say that Toolbox has is there's quite a few features. Like, so right now we're in Toolbox, we run two protocols. We call one the Toolbox protocol and the MCP protocol. Toolbox protocol has a lot of features that MCP doesn't. The reason for that is essentially MCP is trying to standardize. In Toolbox, we were just cobbling together as we were getting out the door, right? So the advantage of that is we moved a little faster and we could kind of bake things in because we had control over both sides. MCP is interested in a lot of the features we have in Toolbox, and we're interested in kind of upstreaming those features into MCP. So one of the things we're working on is like, look, there's a bunch of stuff we have like authenticated parameters that isn't supported in MCP. How can we start to get those things supported? And so that's kind of what we're looking at when we think about MCP is one, we want to get, that broad protocol level support. Then two, we really want to kind of evolve away from our custom protocol and move to a world where MCP can do all of the things we want to. And then it just kind of works with everything, which would be great.
Gotcha. That makes a lot of sense then. So your initial like adding support for MCP would then enable folks to leverage all the benefits of Toolbox, like connection pooling, authenticated requests to database via MCP, essentially.
Exactly, right.
Gotcha. Cool. That's awesome. Looking forward to seeing that. Here's a question from Christo. Are you supporting or planning to add conditional workflows within the workflow YAML files?
I think that's a good question. I don't know what conditional workflows means exactly. There's lots of things we've talked about adding into Toolbox. I think one of the things is a lot of conditional workflows are things where like you want the agent to kind of do those things. So you can do a lot today by just defining, instead of one tool that does like 3 or 4 things based on conditions, you can ask the agent to kind of decide which tools it should invoke instead. If there's a specific use case you have, I encourage you to open an issue on the GitHub, and I think there's lots of cool things that we could do in Toolbox. So it would really be figuring out like what makes the most sense. So if there's like a specific use case that you're not solving with like the agent orchestration frameworks today, it'd be really interesting to see what that is and how we could build that into Toolbox.
Cool. Another question here. Does Toolbox work with Modus? Maybe I can take the first answer to this one. So yeah, I've played around with this a little bit. So Modus is the open source agent framework that Hypermode maintains. If you notice in the demo that I was using LangChain with Dgraph, and the reason for using LangChain is I really wanted to show like how Dgraph can integrate into that ecosystem. I think it's really important. Like I said, for knowledge graphs and Dgraph to support that, to be able to integrate with lots of different pieces in the AI ecosystem. So it's good to see how that works with LangChain. But to answer your question, does Toolbox work with Modus? Is yes, it can. Toolbox fundamentally is exposing an HTTP server. We can query those endpoints to get details on the tool set and the tool information and invoke tools via that the HTTP calls from Modus. It works. I played around with it. We didn't build, or I should say there isn't a full-fledged client for Modus. Like there isn't like nice wrappers over that HTTP API for Modus yet. So what you saw with LangChain is we're using the Toolbox LangChain client. So we don't have to think about like what requests under the hood are being made there. So I think certainly there are more clients coming online for Toolbox. So there's LangChain, Llama Index. Are there other clients currently, Curtis, or ones that you're aware of that are coming down the pipeline?
Yeah, there's definitely some more. I think one of the things that we're trying to do is figure out how to create more standard ones, especially as we reconcile with MCP. So we don't want to have a problem where it's like in by in combinations of, everything has to have its own client and stuff like that. So we're trying to figure out how we can abstract that away a little bit. I think that would be helpful for Modus because Modus uses Go, if I remember correctly, right?
Yeah, exactly.
Yeah. So one of the things, like as we get that Go base SDK, I think that would make it a lot easier to plug into Modus and use that. And so we kind of moved away from these one-off things and said, like, let's figure out how we can provide something more general that covers more use cases, and then really kind of dig deep on the really popular integrations. And maybe Modus will be one, but kind of build that on top of that base SDK and lower the problem of like having just too many clients in too many places. And so for us, there's 4 languages that kind of stand above. Python and Node are obviously very popular in the AI community, but then Go and Java are very popular among enterprise folks. And so, like, I think as we see more productionization of agents, we'll start to see more things in those languages. So.
Gotcha. Okay, that makes a lot of sense then of why you're prioritizing adding language SDKs then on the roadmap then. Cool. Yeah, that makes a lot of sense. Cool. Another question from Christo here. Are we planning to add support for vector databases, which can be really helpful for agentic memory capabilities?
Yeah, good question. We actually support a ton of vector databases already. I mean, Dgraph supports vectors, right?
Absolutely. Yep.
Yeah, and Postgres, AlloyDB, Cloud SQL, Spanner, all of those things have vectors built into them. A lot of them have really handy functions in them as well. So you can do things like embed as part of the SQL statement, which we find super useful. So we already do have kind of support for vector databases. I think one of the things I mentioned earlier was we want to make that support better. So things like semantic search. One of the things we've talked about is putting embedding models in Toolbox, or at least calling them from Toolbox. So rather than having the database call the embedding model, you can have Toolbox call the embedding model and then put the vector into the database instead. So that's one of the things that we've looked at. We haven't had a ton of people ask for it yet. A lot of folks seem okay with the SQL statement, so it's not super high on our priority list. But if it's a thing you'd like to see, again, I would love open an issue and see if we can get some other folks plus one it. So
cool. Another question here. So the examples we showed were, predefined queries in the Toolbox YAML file. But do we have the ability to say, like, let the LLM generate the whole query? I guess that's kind of where like natural language to SQL that you mentioned kind of comes in. Is there that support in Toolbox?
So right now you can only really do it if you know the SQL ahead of time. There's a few things that we've done, like I mentioned, AlloyDB has some statements where they generate the database on their side, or they generate the SQL statement to run on the database on their side. We are looking into like some more general tools. So this is going to be like one of the first things we tackle after next is like what a good analysis SQL tool looks like. I think the biggest thing is we've actually found a lot of folks start with analysis SQL tools, but quickly back away from them. And so with Toolbox, we really wanted to focus on getting something that has high quality, which is why we started with those kind of structured statements. And then we're figuring out like, okay, after those structured statements have kind of got our bases covered, there's some use cases where you just kind of have to use analysis SQL. What should those look like? And so we really prioritize that structured statements. We think it covers the majority of the use cases, but then there's like that 20% where analysis SQL comes in. And so we're looking at both tools that are in analysis SQL where you pass the query and we let the database generate the SQL. We're also looking at tools where it's like you can define some tools and the agent can say like run an arbitrary SQL statement. Those are a little bit more challenging, particularly security-wise, and so we want to be careful with how we introduce those because we don't want them to be abused, but it's definitely something we're looking into.
Cool. Gotcha. We're just about out of time here, so maybe this will be our last question here. On the topic of scaling, how do we imagine managing the tool files, right? So this is where we're defining our tools and sources in YAML. Curtis, I think you mentioned that this idea of a tool set, so we can kind of like group tools that can be shared across multiple agents. But is there kind of a structure or conventions for managing these tool definition files?
Yeah, a good question. I think one of the things I talked about earlier was we really want to have like a proper API here. That might be something that looks kind of like what Kubernetes has today, where you have a bunch of files and you can kind of apply them and modify them and kind of mutate them individually. We're still trying to figure out what exactly that should look like. So if you have any specific opinions, I'd love to hear them. I think right now, the biggest thing is you just, when Toolbox starts, it loads the tool file. So if you make changes to it, you just have to restart Toolbox. Depending on how you deploy Toolbox, like if you're using Cloud Run, this is pretty easy to do. Like our deployment guide, I think deploys the tool file as a secret. You can update that secret, push a new version of Cloud Run, and then all your tools will just kind of propagate down. So the nice thing about that is as long as your tool file is the same, you can have 10, 20, 30 instances of Toolbox. The downside is that as you're rolling those tools out, you have to make sure you're deploying to all the instances kind of at the same time.
Gotcha. Cool. Well, we're out of time here, but thanks everyone for joining, and thanks so much to Curtis for joining the Hypermode live stream with us, and for the cool presentation and answering all the questions here. If folks want to follow up, you can certainly join Hypermode Discord and chat with us there. And Curtis, for folks interested in Toolbox and kind of following up there, what's the best resource? Maybe the GitHub issue tracker that we linked earlier?
Yeah, for sure. The GitHub is the best place to start. Take a look. We're on there every day, so feel free to ask questions and leave comments. So
awesome, great. Well, it's been super fun. Thanks again, Curtis, and thanks everyone for joining today. And we will catch you next time.